Wait, what was the number of electrons we use?
Yeah.
So how many electrons does this one have? I had 32, okay? Everybody good with 32? Everybody had 8. So if everybody has 8, did we have to move any? No.
How do you erase it?
Just hit the blue arrow.
Huh?
Why can't you just hit the blue arrow? Go to new board. That way if we need to go back, it's still there. All right, H2CO.
Why is it doing that?
Might as well do what?
I don't know. It's like connecting it. Maybe it's not writing.
It's not. It's because you don't pick the pen up, pull it far enough away from the board. Because you're not actually having to write on the board. You're just breaking the plane. Right, so you're going to need another board to draw on. People in this battleground can see this one.
I mean, it is unconstant.
Everybody okay with C is the central atom?
Yes. Yeah, that's
All right.
Wait, so do you just?
I did. No, it's the one that's furthest left, but you can't.
Oh. Yep. So you can't use hydrogen. Look at C and O, and C is farthest left on the periodic table. So that's why she picked carbon. All right. And it's drawn correctly. Questions?
I thought it was CO.
Like cobalt? No. All right, look at the size of the C and the O and the way the question was written. Okay? They're both capitalized. If we wanted CO, it would look like that. Okay? All right. Questions? Now, when you put these in originally, and I'm going to erase what Caroline had, you had 12, right? 2, 4, 6, 8, 10, 12. All right. Does everybody have 8? This is the only one out of the 3 that everybody doesn't have 8. H, remember, can H have extra lines or dots? No. So that has its single bond. That has its single bond. It's done. O has its 8. It's happy. But C only has how many? 6. It only has 6. That's why Caroline took these 2 off. And she put them there to share. So C has 2, 4, 6, 8. 2, 4, 6, 8. Questions? Okay. Now, I know some of you were tired. I know some of you forgot. You cannot get good at this if you don't practice. Okay? And I know it's a holiday weekend. You do have some homework with this over the weekend. Okay? And it's on drawing the Lewis structures and telling the geometries. It shouldn't take you very long to do it. But particularly for those of you who didn't do any of it last night, you really need to take a shot at it over the next 5 days and try to draw some Lewis structures so when you come back Monday, you're not lost. Okay? Because we will test with this next week. We will take a quiz with it. I won't do it Monday since we have a 5-day weekend, but we will do it Tuesday. And I'd rather not obliterate y'all on the quiz. Okay? And if you don't know how to draw them, you won't get the geometries right. You won't get the polarities right. Okay? Yes, sir. No, this quiz will not be straight Lewis structures. It will be incorporating the 2 things we're learning today. That's why the quiz is not today. Okay? All right. Now, let's look at homework. Those of you who didn't do the homework, if you want to draw the Lewis structures on your homework or correct them, feel free.
Okay, I have the paper.
Yes, I will get you the paper. You cannot write it down because you have to do it. Diamond, do you have homework? Huh? Okay. I'm assuming that that bag says no late bus?
Late morning.
Huh?
Late morning.
Late brain. Happens that way sometimes. We'll need attention on Monday for you.
Yay, funds. Yes, and.
I believe that means you have it twice. But you returned yesterday too, does it not? So that means you'll have to do 15 minutes.
How long does detention last?
15 minutes.
15 minutes, and then if you have, if anybody in there has extra time.
Oh,
Yeah.
we you got left for like 2 hours.
They only stay an hour,
Uh,
so it roll into the next day.
well, I-
Yep,
Oh, yeah.
I did have you written down to remind you for Monday. All right, can I turn the page? Now, I told you in an honors class that I would I would teach you a couple exceptions. Now, the only one that I showed you yesterday was hydrogen. Boron is the other one that you're gonna have to learn, okay, which is number 3. Boron only has 6 electrons on the outer shell. Okay? It's an exception, and you just have to learn that one. All right? It's the only other exception I'm going to force y'all to learn. Now, the other exceptions we're going to learn are called expanded octets. And they're not really exceptions that are hard to learn because they're going to jump out at you and they're going to be nice and easy, like sulfur, okay, which is number 6 up there. You had how many BRs to draw on the sulfur? 6. So you just draw all 6 BRs around the S, and they sort of take care of themselves. You just have more than 8 on the outer shell. They're called expanded octets because they have more than 8. Okay? But they're not hard to do. They just have more than 8. But boron and hydrogen are the 2 that are going to be the exceptions that you have to learn. I won't give you any more than those 2. Everything else on the paper should have fit your general rules. Have I given everybody enough time to check? Those of you who are just copying, I'm not going to sit here all day while you copy.
Can you go over 5?
Yep, I'll be glad to go back and do 5. All right, there's 7 through 12. And all of the, now on 8, you see how I have the double bond between the N and the O? If you put the double bond between the N and the Cl, that's fine. Okay, I gave that a name yesterday. Anybody remember the name? I think it was Diamond Juice. No, it might have been Lolly. Who said, do we have to know that? You told me my sarcasm was hard to tell if I was serious or not. What was the name I gave for that? A resonance form. Okay? So you can have the double bond between the N and the Cl or the N and the O. Either one is fine. It's called a resonance form.
Wait, so does that mean that the CL only have 2 groups of dots?
Yes. If you put the double bond on the Cl, that means there would be only 4 dots on the Cl. There would be 6 dots on the O.
Wait, 8 on that. Right?
See how there's only 6 dots on the Cl right here? So if you flip it and you have your double bond here and your single bond there, you would do the same thing. So there'd be 6 dots on the O and only 4 dots on the CL. So everything
Yeah,
would
but
flip.
then you still have that, line, right?
Yeah, but you would just have everything would, I'll leave it black. So you would have CL, you would have the double bond, you would still have your dots on the end, and you'd have your O. So the O would have the 6 dots, just like the chlorine had, and then the chlorine would have 4 dots, just like the O had.
Sorry.
Okay? Now, in reality, this is what's going to form, not this, and I won't take off for this because y'all are in the first year class. But chlorine has 7 electrons in the outer shell. If it has 7 electrons in the outer shell, is it actually going to form a double bond if it only needs to gain 1 electron? No, it's not. It's not the element that's going to form the double bond. Okay, but I'm not going to expect y'all to process all of that. Okay, so if you drew this, I would give you full credit in a first year class. Okay, but it's not actually the one that's going to form the double bond. All right, last 2.
Go back up and on it.
Yeah, you're gonna get them all. All right. So you said which one do I need to write? 5. All right. So 5 is which one? ClO2 negative 1. All right. So ClO2 with a negative 1. How many Cl's are there? How many O's? Times how many electrons for chlorine?
4. Sorry. 7.
Okay. And oxygen?
6.
All right. So we have 7, we have 12, for a grand total of 19. And remember what I said yesterday? Well, we have an odd number. Okay. We won't, right? And this negative 1 means what? Devontae just told us what? It means we gained 1 electron. So if we gained 1, we add 1 for a grand total of 20 electrons. All right, who's my central atom? The Cl or the O? Cl, because there's only 1. So Cl's in the middle. We have 2 O's on either side. And then we need to put in 20 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. When I put in my 20 electrons, does everybody have 8? Yeah, it does. So I'm not putting in any more. I'm not moving anybody around. Everybody has 8, so I'm finished. Put in my brackets because I'm a polyatomic ion with my negative 1 charge right there. Anybody else? Anything in 1 through 14 you want me to work? Nothing.
On number 6,
Mhm.
would it be 6 BR
Yeah.
around?
Yeah.
Okay.
So when you get SPR6, even though there are 6, you just draw 1, 2, 3, 4, 5, 6, and you put all the BRs coming off the sulfur. It's called an expanded octet. It's going to have more than 8. Okay, when you add it up, there's actually going to be 48 electrons. Okay, and so when you're counting up your 48, there's 12, and you just keep going. And you're gonna get to 48 when you put all your dots in. And all the BRs are gonna have 8 electrons on them. And sulfur is just gonna have more than 8. It's actually gonna have 12. And it's okay. There's also one that's gonna have 5 that we're gonna do in a few minutes. Okay, it's gonna have 5 lines. It'll have 10 electrons on the central line. Those are the only 2 expanded ones we're gonna do. There are others, but I'm again gonna limit us to 2. Questions? Anything else on the paper? Jay, put your phone up. Huh? Anybody else? So we're okay with Lewis structures? Sorta. Are you kidding me? Now's when you want to reboot? For what reason?
I wish I could reboot.
There are days I won't use swear words in class.
We did, you see?
Go to sleep, go away.
When I used chalk, I didn't have this problem.
You're still going right now? Like,
Yeah, but it's just not.
That's,
You'd rather have a chalkboard?
I didn't have to wait on the computer to reboot.
Chalkboards are pretty fun. I don't like to.
that's what I like.
You sit here and go up there.
I've taught chalk for 16 years. Huh?
I was reading the paper.
that's good. That's all you need, don't think about it, that's all.
It's a long time to dry hands.
Because I got big that day.
Oh.
Oh, I got big on top.
You got bit by what?
They still out there with the flu.
We're in the South. I don't think they ever go away.
Oh, no.
That's gonna get real close.
There's one solution.
Then
Just stay inside.
you've been warm for a couple days. I guess they were like, hey, we can come back out for a little bit. Hey, no. It's like, right, hey, that's what you get.
I hate mosquitoes.
Hey,
Squeeze
I'm like, all right, y'all rude. You know, like when you hear like swarms in the house.
Well, this is
Like ranch.
a mission trip when they take the vaccination.
Like,
And I always get bit mosquitoes, and I got bit on that.
Okay, yeah, I'd be like,
I was bringing that as an example there. This was right?
I regret all that.
They
When
were
I was
all
in
it's
Mexico,
Firefighter.
it's big, like, I was like, yo, bro. I was telling her that, I was like, yo, like, I know you want to be like, I want to go, bro. I'm tired of seeing big things.
All right, let's see how it feels now.
Reboot. I hope they're rebooting.
Shut up over there.
Oh, yeah. Yo!
Don't you have one of the nicer smart boards and stuff though?
Yeah.
Mine and Miss Thornhill's are 4K TVs that operate with Smart Notebook. And Mr. Johnson's and Miss Walker's are, they use apps. They're a different type of smart. It's not, theirs isn't a smart, theirs is a different type. But theirs is pretty nice too.
The answers.
I like physical class. Like, that was a pretty fun class. And it was always cool in there. I excluded from Spanish 1. I taught all the time. And it always felt so long.
All right, for those of you who like titles, modular's geometry.
Wait. Best
Okay.
part.
Hard.
It's just small. All right. So, do we what? Yeah, this is all still a continuation of what we've been doing. Okay? These I just typed a few years ago for some odd reason, so I just use them because it's written neatly. Now, we're going to talk about valence shell electron pair repulsion theory. We use VSEPR for short, just because it's a lot to say valence shell electron pair repulsion theory. Okay? It is. All right? Now, what do we know valence shell means? All right? We all know repulsion means to push away, push back. Okay? Electrons have a negative charge, right? Yeah, they don't like each other. So if Lolly and Angel are both negatively charged,
I don't like you.
that's right, they're going to push away from each other. Electrons in the molecule are negative. They don't like each other. So they push away from each other. So in a molecule, they try to get as far apart from one another as possible. All right, they repel. Since they are trying to get as far apart from one another as possible, molecules arrange themselves in a way that the electrons will be as far apart as possible since they repel each other. That's really all valence shell electron pair repulsion theory says. Okay? I know it's a long word, but if you four are electrons, all right? You're not going to sit in a square on a molecule. That you're going to arrange yourselves in a way that you're going to be as far from one another as possible. Okay? Now, are molecules flat? No. Molecules are three-dimensional. So they're going to arrange themselves in a three-dimensional way to get as far from one another as possible. I'm going to show you with some models. Now, all right, this is the only slide that has a bunch of writing on it. I'm even going to give you a handout with the geometries. Now, due to an atom's arrangement, each compound can be identified by a geometry. This is where students struggle, because you have to learn the geometries. All right? The geometries can be determined by where the atoms are and the lone pairs of electrons. So we have to look at where the atoms are and their lone pairs. Now, who can tell me what a lone pair was from yesterday? Anybody remember what that word was? They're the dots. The dots are the unshared electrons. They're the ones that are not involved in the bond. Okay, so those lone pairs are going to be important, and the atoms that are involved in the bond. Those two things are what we're going to look at. Let me think about it for a minute. No.
And we have a Christmas get together.
Sure, Charles' house is knock yourselves out.
And we do it in there, right there.
I would bet y'all could even guess in 28 years how many Christmas parties I've had.
Okay.
That's some sad years.
Yeah.
You need to set your
Like,
best
no
year of
years
my
are so
life.
weird,
It is
like,
sad.
We need to start set, right,
Best
make
year
your
of my
student
life.
lessons.
When I started teaching, the principal that I taught for allowed zero.
Well, it's not
That's
right.
not
around no more. It's just the way I started. And I have continued on in that same.
Are you
Right.
serious?
Wow.
Wow. Let's go find out.
I am sure you will have other classes that allow you to have a Christmas party. You will not be deprived. So why on earth are you complaining?
Because nobody's gonna be focusing really that day. and then-
Well, we will,
That's the
you will in
only-
first period, and then you'll be free to do what you wish, second, third, and fourth. Now, to determine a geometry, we have to know two things, okay? These are the reasons we have to be able to draw Lewis structures accurately. If we cannot draw Lewis structures correctly, then we are going to struggle with these two things we have to find, okay? We have to know the number of atoms on the central atom. So you're going to have to look at your Lewis structure. And you're going to have to be able to go, oh, I have 5 atoms on my central atom. I have 2 atoms on my central atom. I have 3 atoms on my central atom. And then I have to find my number of lone pairs on my central atom. Everything comes down to the central atom. How many lone pairs do I have? Now, the reason I said it's important to know the number of atoms, the number of lone pairs, is because if you have a double bond, does it say anything about a double bond up there? No. But if you put in a double bond, it's going to take out a set of lone pairs. Okay? So it's going to alter your Lewis structure. So if you draw the Lewis structure wrong, you're going to get your geometry wrong because you're going to have left a set of lone pairs that probably shouldn't be there. Okay? So that bottom section is where our geometries are going to come from. Now, I'm going to walk through some stuff that I'm handing you on a chart. I'm handing it to you on a chart so you don't have to write it all down and we can cruise through a little faster so that we can practice today. But most of you don't have anything to practice with, which is going to create some issues. Now, the stuff that's on the chart, you have to know. By the Tuesday, we come back from break. So, those of you who know yourselves, and you're like, I ain't doing anything over Thanksgiving. When you return Monday, you have to know this what day? Tuesday. If you know that you cannot learn this Monday night, you are not someone who can memorize in a day. Not your skill set. Okay? I don't suggest you wait till Monday night. Now, we're going to walk through where this stuff comes from. Now, where do geometries come from? You've got all this in front of you. You do not have to write it down unless you just want to. Some people like to write because it helps them with their notes, okay? But I've handed it to you. So, as an example, if you have something like CO2, reset. All right, if you have something like CO2, which is up there right in front of you, all right, you have a molecule. If I was to connect this O to this O, pretend you're sitting in geometry class, what would happen if I connected them? What would we get? I have a ruler. What would I get? A line. Okay? Because I would get a line if I connected them. That's why we call that geometry linear. Okay? Now, how are you going to figure out the geometry after you draw it? All right? What did we just say we use? The number of atoms on the central atom. What's the central atom? What? I heard it. It's carbon, right? Now, how many atoms are on the central atom? Well, if this is the central atom, how many atoms are sticking off of it? 1, 2. So how many O's are sticking off the central atom? 2. How many lone pairs are on the central atom? Look at your carbon. Almaja, how many lone pairs are on my central atom? 0. How'd you know it was 0? Because you read it. That's not going to help us if that's all you got, because you're not going to be able to read it on the quiz. All right. How you going to know it's 0, Devontae? There aren't any dots on it. When you look at the C, there's 0 dots on that C. Okay? Does everybody see how we got that? There are 2 O's. There's 0 dots. That's going to tell you it's linear. Everybody see how we did that? Now, what if you have something like HBr? How do you know that's linear? It is a straight line. What's it say right below it? There's what? There's no central atom. Anytime there's no central atom, it's automatically going to be a straight line. Okay? There's no central atom. It's going to have a linear geometry. Now, what if you have something that is did I write the bond angles on there?
Yeah.
I did? Fabulous. I'm ahead of my game. All right. If I have this, what's that? How many atoms are sticking off of it? All right. How many are sticking off there?
3.
There's 3. That's what I want. What's the shape? If I connect it. It's a triangle. Okay? Everybody see that? Sometimes it helps to remember the names if you can see it. It's a triangle. All right, so these days my grip's going to improve. All right. So if you want, you can write it as a triangle. You can abbreviate. Now, it lies flat in the plane of the board, so we call it planar. All right, triangular planar. It had how many Y's? 3. And it had how many lone pairs on the central atom? It had 0. So 3 and 0 is triangular planar. Now, those are the only ones that are flat. Everything else on there is 3-dimensional. So, and I drew this one 2 ways. So most of y'all are going to draw this way. It's not a problem. Y'all are going to draw it flat. I draw it flat when I draw it for y'all. All right, how many CLs do we have?
4.
How many lone pairs on the C?
0.
Okay, now, is this molecule flat?
No.
No. Okay, now, y'all have been in geometry class before. Are those bond angles 90 degrees?
Yes.
No.
They don't look 90 degrees to me. All right, let me do it with this one. See if I've got something brighter than black here. Got 3 reds. I'll find the 4th one. All right, it might be a little easier to see. Does that bond angle look 90 degrees?
No.
No. All right, greater or less than? Greater than. Okay, so can I get it to lie flat in the plane of the board? No, you can clearly see the one sticking out in the front, and I took one off of the back. Okay, so how do we demonstrate that in chemistry class? All right, I drew it on your sheet. All right, these 2 lie flat in the plane of the board. Okay, and on your sheet, I drew it so that I drew a little triangle showing that sometimes we draw it shaded in And that shows in front of the board. And then the broken line is behind the board. Okay? Now, I'm not going to expect you to recognize that ahead of time and draw that. You can draw this for me every day of the week. Okay? But I need you to recognize that this is flat. Is the molecule itself going to be flat in real life? No. All right, what bond angle did I put this down on the sheet? Because I need you to know the bond angle. 109.5, okay? Even if you just tell me 109, I can live with it, okay? Now, here are your two expanded octets. What are the two expanded ones I gave you? All right, how many do I have coming off of it?
5.
All right, so you've got one that's got a triangle shape. All right, so take the one that's got the triangle, okay? And then it's got two pieces sticking out of it. So I'm going to put one on the top and one on the bottom so I can illustrate how that works for you. So there and there. And then you got, move that one down. Then you got all the dots that go with it. Now, so you got 5 and 0. Now, let me use Angel for a second. What does it look like if I do this?
Pyramid.
Okay. And I do that. I can't do it very well.
I think it's called. Yeah, that.
Is it another pyramid or not?
Yeah.
Okay, so I have how many pyramids? Okay. So we call it bi, because in science class, bi means 2. So bipyramidal. So we have triangular, bipyramidal. Now, you can sound really smart and say bipyramidal if you want, but triangular, bipyramidal. Now, the one you had on your sheet a little bit ago, SBR6. And I'm not drawing the dots this time. So that had 6 with 0. That's called octahedral. Now, everybody always asks me, how's it got 6 as well, but it's got a name of 8. All right, octa has to do with the quadrants, not, let's see here, 1, 2, 3, 4, 5, 6.
Do we need to write that?
It's on your paper.
Okay.
Flip it over. I gave you all of this. I'm giving you. You just got to learn it. I'm just explaining what's on the paper. You can use flashcards, Quizlet, whatever you want. You just got to know it. All right. So, if we had paper, and we could actually put paper through here and through here, there's 1, 2, 3, 4 quadrants on top, and there's 1, 2, 3, 4 quadrants on the bottom. So there's 4 quadrants and 4 quadrants, and this makes how many quadrants in the molecule? 8. That's what it's called octahedral. It doesn't matter that there's only 6 actual molecule or atoms sticking off of it. It's got to do with quadrants. Does that make sense? Okay, that's why it's called octahedral. Now, all of those that we've just looked at had how many lone pairs? 0. So everything else on the sheet has how many lone pairs? It's the ones that have the lone pairs. So if you look at the back, what makes linear different from the other 2 that are on the back? All right, look at it. All right, so if you look at the X that has this, how many atoms are sticking off that X? And how many lone pairs? And if you look at this one, how many lone pairs? And how many atoms? Now, what were their names? What were their names? They're bent. Now, do you have to tell me the difference between the 2 bents? Bent is bent. You do not have to tell me the difference, okay? Now, what's the difference between these two and linear?
They have this low.
What?
It's not a straight line.
It's not straight, okay? It would actually look like, I'll take these off. It would look like this, okay? That's what the molecule itself would look like, all right? Whereas linear would look like, let me get my fingers on it, which is, linear would look like that, okay? Bent would look like this, okay? Now, but how are you going to tell the difference between the two? What's different between these two and that one?
Wait, go ahead.
Okay, look at the way that looks. That's linear. And that's bent. So you've got to figure it out on a quiz or a test. What's the difference? Okay, those two have lone pairs. Okay, and linear what? And linear doesn't. Okay, when you look at linear, linear has no lone pairs. Okay, so when you draw it, there's no lone pairs on linear, and bent either has one set of lone pairs or it has what? Two lone pairs. Okay, same thing with the last one. The last geometry has three and one, and its name is triangular pyramidal or pyramidal. And how is that different from triangular planar? Triangular planar had what? Had no lone pairs. Triangular pyramidal has what? Had a lone pair. You see the difference? Yes, no. All right, find your homework. If you did homework, this is why I wanted you to do your homework. Now, we had 14 structures. I want you to tell me the geometry of your homework. If you got no homework, it's sort of pointless. Oh, look who's here. Angel. You got any homework from last night? Huh? What? Homework from last night. Oh, I take it that's a no. Well, consider that a zero. Let me add you to my list of people to remind on Monday that you have detention.
Wait, question.
Yeah.
If you come in like 9:15.
Oh, never mind. He's just absent. You don't have detention. You just absent.
No, he's been here.
How long you been here?
You've been here about 10. Yeah.
That's still after 9. He wants
It's
to
actually,
know.
the time is actually not.
I thought it said it gotta be like over half.
I did that, so yeah.
That'd be what? I'll probably count it for you.
What? You just gonna give him a decision?
I
mean.
That'd be what? 50 minutes out of, that'd be 50 minutes. You'd be right at the cutoff point. If you got here at 9:05. Y'all sure he got here that time?
Yeah, he
I
did.
saw him, but.
He walked in the room.
Yeah.
I don't know if I want attention.
She did not.
No, she didn't.
No, you
You
got
didn't realize it? I was.
Suck it up, boy. You know, the fix to this is just get up and come to school. It's hard. You know, I hope when y'all are actually being paid to be somewhere, you know, because
Oh, yeah.
students
I mean,
keep telling me that it's
Being paid,
because y'all get
yeah.
paid to come to school. That, you know, it's easier for y'all.
If I got paid to go to school.
I'll
be here on time every day.
We got 5 minutes
So
early.
you don't have any trouble getting to McDonald's on time.
Oh, yeah, I'm late to work
I'm always late to work.
every time.
Why y'all like to work?
I'm like to work like every.
That's what I'm thinking. Why?
Because,
I'd fire y'all.
Men just come
So-
in 30
No,
minutes late.
my
I tell you, I
daughter,
don't need my job.
Or they don't call in.
as long as they come in within 2 minutes.
So I did not.
There's one other came in an hour.
I'm a great worker. I'm believe it or
What
not.
time?
I work.
They need to speak up.
All right, find your homework. Because we've still got polarity to do today.
That sounds not bad.
It's not hard. It does help if you have stuff to practice with.
You know what?
Find me the geometries quickly. What?
Can you make your 2 pairs of 1 pairs?
What?
I mean, what is it? It's like you have 4 dots on the, like it looks linear, but this doesn't look linear.
You shouldn't have 4 dots in no one thing.
Yeah, 'cause it's 20.
It's 2 lone pairs.
Yeah. You don't know if it's that bent.
It has to be bent.
That's what I was gonna ask, like,
But
does
I
it
didn't
have
draw
to be
bent.
bent if it's?
Huh?
I didn't draw it bent. I drew it straight.
It doesn't matter. It's still bent. It doesn't matter if you drew it straight. It's still bent. Just because you didn't draw it bent doesn't mean it's not bent. Remember, you didn't know it was bent when you drew it. I know it's bent. So sometimes I'll draw it bent. Like, look at number 5 up there. What would you say that geometry is?
Yeah, we see it. Too many ourselves.
It's bent. I didn't draw it bent, but it's bent. Remember, it's 3-dimensional. Just because it's lying flat in the plane of the board doesn't mean it's not bent. Y'all phone.
Okay.
Uh-oh.
I was just gonna see the time.
Right.
I have notifications on things now.
There's a clock right there on the wall.
I can't see it, the glare. Like,
Oh, yeah.
shit,
Oh,
there's
yeah,
a
you
glare.
can't see
going
the,
on.
you can't see from the 4 to the 8. You can see 6, 7, 5, and 9.
I can't see the line of
I can see
the.
it.
I just can't
Or
see.
921.
I can't really see.
Seriously?
Yeah.
Oh,
Yeah, I don't know what to do for, 1, 2.
1 is 2 atoms side by side. There's no central atom.
Oh, I didn't even.
okay, what about this one?
Which one?
It has 3, but it's got 2 atoms.
Yes, that's the one I needed to
You want 7? That's what I'm talking about. It's got 2.
Wait, 3 was 1 lone pair.
That's 7, that's a triangle.
7. Oh,
It's got 1 pair.
I need 11.
11 has 4. Now hold on, I'm rolling off 13. 11 has 3 and 1 lone pair.
Yeah, so it's the same 7.
Does the same as 7.
Yeah,
Can we look at have like abbreviations?
The only thing you can abbreviate really is a triangle.
Yeah.
So you can draw the triangle instead of writing triangle.
So like, for this one, I could not draw TT.
No, you cannot put TP.
Wait, so because you actually.
You can draw a triangle instead of writing triangle. That's the only thing you can abbreviate.
Will we be given the pictures or we have to write that?
You know, it did not say.
Like on the quiz, if you ask if like I2 is.
You have to draw the Lewis structure. All this quiz is entirely for response.
Oh my god. But I have a question. Okay, so 14 is only 2.
There's 2 atoms, there's no central atom. So if there's no central atom, it's automatically what? Here.
What?
Does this look like this one?
I get ready to go. Alright, so we're looking at number 1. If there's no central atom in number one, what is it automatically? In number two, you've got the same thing, so it's what? And number three, what do you have? That's right, there's 3 chlorines, there's no central atom. And number 4, triangular planars, 3 O's, no lone pairs on the central atom. Number 5, bent, there's 2 and 2. 2 O's, 2 lone pairs, bent. Number 6, I should slap you, it's obvious, there's 6 BRs.
I thought you were like, I was like, it's not right.
You remember that I'm 2.5 years from retirement, I'm not slapping anybody, ever. All right? I can have all the internal conversation I want to have with myself. I can swear inside of my head till the cows come home. I just can't utter it. All right? Never.
She'll probably get time to talk about this rookie.
Okay. Number 6 is octahedral. Okay?
Well, you can be a sub after you retire.
You know, I've had several people say that. And I guess it's not a bad idea because I wouldn't have to bring anything to work. I wouldn't have to take anything home.
That is
You know, I would just do what somebody left, and if it didn't get done, it didn't get done. Just make sure there's no bloodshed on the floor when I left. But I don't know. I'm not sure I want to do that. Yeah, that's what Jada just said. If I thought about that, I was like, I don't know. All right, number 7. PI3 would be what?
Triangular pyramid.
Triangular pyramidal. Number 8.
Triangular.
All right, how many atoms do you have coming off the end?
Oh, look what I wrote. This one. Because I wrote
2. The N
Oh, yeah.
only has the O and the Cl, so it's just 2. Even though there's a double bond, it's just 2 atoms, just the O and the Cl. And then 1 lone pair, so 2 and 1 is what? Bent.
I wrote 2 C.
Okay, and then 9 would be tetrahedral, and then 10 would be bent, and 11,
Triangular pyramid.
triangular planar. Why'd you say planar on 11?
That's it.
I said one.
Look at 11. Do you see any lone pairs?
Yeah.
Yes, triangular what? Pyramidal. Okay. Pyramidal, it's got lone pairs, so we can't say planar. All right. 12. Okay. You got 2 and 2. All right. And then 13, tetrahedral, and 14, linear. Okay, you got the hang of it? Now, the obstacle for most people in this is what? What's the hard part for most people in this?
No, which ones
have alone?
Yeah, and actually learning the geometries, because what can't you have on Tuesday on the quiz? That paper. Okay? Now, do you have to know the example column? No. Okay? You do not have to know the example column. You have to know the name, the central atom, and the lone pair column.
So no angle.
No, you have to know the angles for linear, triangular, planar, tetrahedral.
That's the only 3?
Yeah.
Which linear? There's linear. Okay.
I will make us.
Linear is linear. Line is line. Just like geometry class. Okay? Now, you can make flashcards, you can use Quizlet, there are all kinds of different ways you can learn them. You just let them memorize the sheet for all I care. But you got to know them. Now, I will tell you the bond angles you will not need to know until the test.
What?
The bond angles you will not have to know until the test. They're not on the quiz Tuesday. Okay? All right. So polarity. So for those of you who like to label your notes. All right. Oh, heck no. Oh, heck yes. All right. You have to be able to tell the difference between bond type and molecule type by the time you leave today. The hot topic. All right. Bonds can either be ionic, polar covalent, or non-polar covalent. Most of us, or a few who couldn't do this yesterday. Okay?
What do you call this?
It's up there on the board. Number 4, polarity of molecules. That's the title. Okay? So, bonds can either be ionic, polar covalent. All right, we determine the type of bond using the electronegativity scale. So, now, I put this here to remind us that the type of bond, we use the scale. Because these questions are going to begin to run together, and some of you will be like, what are you asking me, Ms. Wall? If I say type of bond, we're going to use that scale. Okay? If I talk about molecule type, which is what we're getting ready to do, we cannot use that scale. Okay? So, yesterday, when we had CCl4, we would have looked up carbon, and we would have said 2.5 minus 3.0. We would have gotten 0.5, and y'all would have said it was polar covalent. Right? Now, today, we want to consider the whole molecule, okay? And that 4 is supposed to be a subscript, by the way. It's a small typo. So, now, we want to consider the entire molecule of CCl4. What would happen to its polarity if we consider all 4 bonds? Would it be still polar? Would the molecule become nonpolar? Does it change? All right, we caught up? Nope, okay. All right, so is everybody with me? So we know how to subtract to find the type of bond. Yesterday's quiz was about bond type. Today, we're going to talk about molecule type. Okay, so you've got to pay attention to the wording in the question. If it says molecule type, we're going to learn something new. If it says bond type, we subtract. Is everybody with me on that? If it says bond type, see what I boxed it up there in the green? Then we subtract using the electronegativities like you did yesterday on the quiz. Right? If it says molecule type, that's what we're getting ready to learn today. All right. Have I given you enough time to catch up now? My mind's just still right. You want me to wait?
No.
Okay. Now, a molecule is nonpolar if it meets 2 requirements. Now, if it doesn't meet both requirements, it's automatically what? It's automatically polar. Okay? You have to meet both requirements to be non-polar. Everybody with me on that? If you don't meet both requirements, you are automatically a polar molecule. Okay? So, what are these two requirements I speak of? Now, number one, all the dipoles are equal. Now, nobody has any idea what a dipole is. A dipole is just the difference in electronegativity. So, up here, where I subtracted and got this 0.5, technically, that would be a dipole. Okay? So all the dipoles would have to be the same. Now, sometimes I have students who want to subtract those every single time. I'm going to show you a way to do that where you don't have to subtract. I don't ever subtract. Or very rarely. Now, the second thing is the dipoles have to pull in equal and opposite directions. Now, how do we know if they're pulling in equal and opposite directions? Well, bond angles are equal. Well, how do we know if the bond angles are equal? What I put there in big capital letters. There are no lone pairs. Okay? We know that the bond angles are equal and opposite if there are no lone pairs. If there are lone pairs there, the bond angles are not equal.
As well.
Mm-hmm.
Do you ever get tired of teaching this stuff?
No, probably should.
I'm tired of learning.
That's what you're math. Straight to.
Say what?
You mean
Muscles in the back of it, straight to.
Certified to teach math. I just don't.
You thought you were too odd to use your words?
I've branched out a couple times to talk from out of field.
What you teach?
Math. I've even taught history once.
Can't what's history?
Not technically.
Oh, see, yeah, I see that. You don't say.
I can see the history of that one.
Jesse.
I didn't enjoy the history experience at all. It was an experiment for principal. I didn't enjoy that at all. All right. So if we look at those two requirements, okay, we want to figure out if a molecule is non-polar. Everybody got it? All right, we're going to start with an easy one. We're going to take the same molecule we had up there, CCl4. Okay, so carbon's in the middle. We got 4 chlorines. All right, and you might want your electronegativity tables, but I'm going to put the numbers up here, so I don't think you'll need them. I'm thinking about it. And I left your papers on your desk for you, and I picked them up, Angel. Okay. I knew I was picking them up, but I couldn't remember if I got them on. I know I've still got to get sailors. All right. Everybody got it? So, go on through, Mercy. Go on through. We'll wait on me. So, when you look at CCl4, is the electronegativity between carbon and chlorine going to be different? Yes. Now, if they're the same, Now, if you have a molecule that the electronegativities are the same, it's automatically nonpolar. And that does happen periodically. There are a couple elements that you look up, like P and H sticks out in my head. Phosphorus and hydrogen both have a 2.1, okay, when you look on your electronegativity table. So if you have that, then you subtract, you get 0. It's an automatic nonpolar molecule because you don't have a dipole at all. So can they cancel? They already canceled. So it's automatically nonpolar. Now, when you look up carbon, carbon is 2.5, chlorine is 3.0. Now, what's the difference when you subtract C and Cl? Can y'all do that without a calculator?
Yes.
What is it? 0.5, right? Now, who's bigger? Now, the way that we would draw this is we would draw an arrow pointing towards Cl because it's bigger. It's more electronegative is what we say. Carbon is more electropositive, so we put a little plus sign there. And then we write 0.5. That's how we show the dipole. Okay? Now, you don't actually have to do that. I'm just explaining how it works. Now, hate drainage. Now, as you look at all 4 of these bonds, can we agree that all of these bonds would be the exact same? How do you know they're the exact same? Okay, they're all carbon and chlorine bonds, right? Would we have to look up their electronegativities for all of them? No, because we can all agree they're the same bonds, right? So the 2 rules, they have the same bonds. We got that one covered. Number 2, no lone pairs on the central atom. Now, in order for the dipoles to cancel, these 4 chlorines have to pull in equal and opposite directions and cancel. We know they pull in equal and opposite directions if there are no lone pairs on the central atom. Are there any lone pairs on the central atom? So we meet rule 2. What does that tell us about this molecule? Questions? You with me? We're going to lose you. Well, I can't work with that. All right, so if I have water, is it polar or non-polar? What can you tell me about the dipoles? All right, if we look up O and H and O and H, all right, O, I think is 3.5, but I can't swear to it. It might be 3.0. 3.5, H is 2.1. So when I subtract them, I'm going to get what? Are they going to be the same or are they going to be different? They're going to be the same. Now, do I need to do that every time? No. What can you tell me about this bond and this bond? Are they the same or are they different? That bond here and that bond here are the same. They are the same 2 bonds. Okay? Number 2, they have no lone pairs. Oops, I left off the word. No. No lone pairs on the central atom. Do I have any lone pairs on the central atom? So, what does that tell us about this molecule? It's polar. Okay? Because I defaulted on step 2. I have lone pairs on my central atom. Does that make sense? Other than I'm tired. Yes? No? All right. What if I have Do I have the same bonds? Do I have no loan pairs? So what do I have? What?
Wait, what if the CL at the top is a BR?
What if what?
The CL at the top is a BR.
Doesn't matter. Are all my bonds the same?
That would be all the same.
Correct. You with me? All right, one last one. I said one last one because it's going to stump some of you in a second when we practice. What if you only got one bond?
Yeah.
What do we do? Yeah, we do. Gotta do something with it. We just go skip it?
Yes. Just let it.
How do you know?
Yes, it's only one bond, so there can't be anything different. And there's no loan pairs. It's for so that makes any sense.
There's only one bond. It's a single bond. All you do is use your electronegativity scale. We do not just skip it. That is a terrible idea. All right, if there's only one bond, meaning no central atom, you use your electronegativity scale, just like you would always do. So you look up H, which is 2.1, and then Cl, I think, is 3.0. You subtract, you get 0.9, and 0.9 would tell you it's what? Central atom. Questions? So you got your homework handy? Let's run through it real quick. All right, can I take this down so I can pull up homework for those people who have nothing? Here's homework for my people who have nothing. So y'all can look at it and see if you can figure something out too. Now, mind you, got homework, so try to look alive for 10 more minutes. Then you can look dead in the second period. Don't worry, you're not the only one looking dead. I'm just picking on you. Today's just not looking too spiffy beside you either. Alex looks like he's preparing to go to the Arctic back there. Basketball must be killing them. No homework. They can barely stay awake in class. Golf's not a bad way to go.
I'm so serious.
I wanna play too.
See, I'm
I
not
wanted
good
to
at
swim, no, I honestly want to
I
swim.
like golf.
It's during basketball season.
That's fabulous. Come on, find me some answers quickly. We don't have much time.
Yeah, right, this,
You're using your homework to figure out the polar and nonpolar molecules. Quickly. This stupid thing just rebooted again.
No, you just tell them.
You gotta do the homework without y'all being able to see it.
I'm confused what we're doing right now.
We're taking the homework and which you don't have, and trying to figure out if it's polar or non-polar. That my computer just decided to reboot again.
So if it has any lone pairs, it's not polar.
If it has any lone pairs on the central atom, most likely it is polar. The only thing you need to check is to make sure it's not zero when you subtract. If it's zero when you subtract, it's going to be non-polar.
So what we wrote the rules down for was to make sure it was non-polar.
Yes. Those two rules make it non-polar if it's yes on both of those. All right, we done them all?
No, I can't find it.
You can't find your homework.
I really just had it.
You lost it.
Yeah, I just had it. Okay.
You and the 8 zillion
I found
slicky
it.
pockets over there, face protectors.
That's funny.
If they have a home
Do you know what this is called?
and it's
A
biting.
It's
It's not.
unstable.
That's an unstaplenator.
Oh,
yeah.
I like
Yeah.
when you try
Oh,
it,
my
it's
God,
called
you told
the
me.
legs.
Yeah, some freshman from Miss Bostic's class came over. It was
Yeah.
last year, and he said, Miss Bostic sent me over here to borrow an unstaplenator. I go, what?
She really did.
I don't even know what that is.
I stuffed my sister.
All right, so number one, I2, what would I2 be?
Non-polar.
Non-polar. When you subtract, you get zero. HBr,
Non-polar.
I don't know. I would call that be polar. Okay, I would think when you subtract, that'd be greater than 0.3. All right, BCl3, non-polar. No lone pairs, and all the bonds are the same. NO3, non-polar. No lone pairs, all the bonds are the same. ClO2,
Polar.
polar, it has lone pairs. SBr6,
Non-polar.
non-polar. PI3,
Polar.
polar. ONCl,
Polar.
polar. SiCl3Br,
Non-polar.
that's polar. All the bonds are different. Okay? Okay, you don't all have the same bonds. SCl2, polar. NH2Cl, polar. The bonds are different. Cl2O, that's polar. CH4,
Non-polar.
non-polar. O2,
Non-polar.
non-polar. Questions?
Yes.
All right, start homework. All right, on this homework sheet, there are 3 columns. This back part, you are stopping at the table, okay? Don't do the short answer crap at the bottom, all right? We're only doing the table. In the first column, it says bond type. What are you doing in the section that says bond type? You're subtracting electronegativity. In the middle section, it says Lewis structure / geometry. So you're drawing the Lewis structure, you're telling me the geometry. In the in the little box. In the last section, it says molecule type. What am I asking for under molecule type? Polar and non-polar, using the 2 rules we just learned. Okay? This is what your quiz will look like on Tuesday. Okay? Like I told you, those of you who know you cannot get all those geometries learned in one night, you need to take some time over the holiday and try to put those in your brain. If you're Almaja and you're moaning about your grade, if you can't find some time to do that. And yes, I have schoolwork to do over the break too.
I bet you're not thankful for it.
I'm not thankful for schoolwork, no.
So you have to suffer.
If we hadn't lost 3 days to Hurricane Florence and Michael that were not being made up, I normally do not assign any homework over Thanksgiving. You will not have homework over Christmas.
Yes.
You will not.